Okay, welcome to 2.7 part 1. In this section, we're going to be transforming a parent function again. So before we get too far into it, I want to review with the x squared. Okay, so we did this in the previous section, 2.6 with the x squared, transforming it, and literally all that's different in this lesson is we have a different starting parent function, which is the absolute value of x. So before we dive into that, review these quick, pause the video, and then I'll go over. How are they different, right? The question here is how are they different than this parent? Okay, so quick review. The x squared function is just a parabola U shape, all right? And then we can transform it, stretch it, compress it, move it up or down, reflect it, all that kind of stuff. And so this on the inside moves this left or right, opposite of what we think. So I believe this would go right 4, but I actually make the parabola shape just go left 4. So it's going to be the same shape up here, just move to the left 4 over there. All right, number 2, the minus 3 part, similar to what we were just talking about. You'd think that would go left 3, but that's actually going to go right 3. And again, that's because it's inside with x, that goes right 3. And then the negative, this is the hardest part, is a negative makes it reflect, and you can go either over y or x axis. And when it's inside here with x, that means it's going to flip over the y-axis. So this one's going to reflect over, wow, not great, reflect over the y-axis. Okay, if it was on the outside here, if the negative one was on the outside, then it would go over the x-axis. Right, and that's actually what's happening here, I guess. Number 3 would be an example. Negative 1 on the outside, so that's reflect over the x-axis. And it's also going to go right here. That would be opposite what we think, so that would be right 3. And this one, it doesn't matter necessarily, but the order you would go right 3 first, then reflect. Okay, last one. If you multiply by a fraction like this, actually any multiply is like a stretch or compress, and because this is between 0 and 1, this was going to compress vertical. So this is going to be a vertical compression by factor 1/3. Sorry, that word doesn't show up there very well, but by 1/3. Okay, so that's a quick review, and I'll get into the new stuff. So literally today, our objective is to graph another parent function, right? But all it's going to be different is it's an absolute value. So if you want to get down a goal, our goal is to graph absolute value functions, and it's going to be the same thing as we just did with the x squared. All right, so next thing for sure to get this down in your notes is what does the parent function look like? Okay, so we have a starting parent function, just the most basic function. That's what a parent function means, without any moving it up, down, left, right. So get this down in your notes, all right? And so the basic one is going to be y equals the absolute value of x, all right? And so if you want to actually figure this out on your own, one, you could graph it on your calculator. That'd be one route. You have to find that absolute value button. I think it looks like ABS on most calculators. You can graph it on a calculator, or you could just do a table, right? So like when x is -3, if we do the absolute value of -3, that's just 3, right? So we could graph that point right there. Absolute value of -2 is 2. Remember, it just means how far is it from 0 on a number line. So there's -2, 2, 1 here. And then the absolute value of 0 is 0. Okay, and then when x is 1, the absolute value of 1 is just 1. How far is that from 0 on a number line? It's just 1 unit away. So that's the point 1, 1, 2, and 2. Absolute value of 3 is 3. All right, so you can see it kind of bounces at 0, and you get this V-looking shape. All right, so I'm going to connect the dots here, and that's what your basic parent function looks like. Okay, and so all you got to know for this lesson is this shape, this V shape for absolute value, and then how do you transform it? Okay, so if you want to do a big summary of this, all right, so here's all the ways you can modify it. You can slap a number on the back of it, a plus minus number, and do you remember what does that number on the back do? All right? So on the back, it makes it go up or down, okay? And if you add a number back there, it's going to go up. And if you subtract, it's going to go down. All right. H, again, this is like an add or subtract number, and this makes us go left or right opposite of what we think. Okay, so let's just do an example. So if you want to go left, we would have, as an example, inside the absolute value, we'd have x, say like plus 2. That would actually make us go left 2. Okay, and then to go right, it would be like x minus 2. That would make us go right 2. Okay, so the A number again does a whole bunch of different things, right? So it can stretch, which we already talked about. And I would do an example there. So A has to be bigger than 1. So if you want to do an example, I guess we could just leave it that way, but an example like A of 2, that would make it stretch. Compress, A is between 0 and 1. Okay, and again, if you want to do an example, something like 0.5. And then the final thing that A does is it can reflect. Okay, so if it's on the outside here, if you have like a -1 outside there, it's going to reflect over the x-axis. Okay, and if it was on the inside with x, then it would be reflect over the y-axis if it was right in here. All right, so that's pretty much it. So the rest of this lesson is just going to be questions along those lines, and you can use this little setup here as your guide if you're not sure. Okay, so here we go. What would this plus 3 on the back do? What do you think it would do? All right, so hopefully what you realize is all that happens is this makes us go up or down because it's outside of the absolute value. So this is just going to make this starting point be up 3. So we're going to have the same points as we had before, just 3 higher. Okay, so I'm going to graph my same V shape like so. It's the exact same shape, just up 3 from where it was before. All right, plus 3 on the inside now. All right, what is this going to do? Again, I would pause the video here and try and figure it out on your own before continuing. Okay, so on the inside goes left or right, opposite of what we think. So I would imagine this going right 3, but it actually goes left 3 and ends up over here. And then we literally draw our same shaped V as the original V, just over to the left by 3. All right, next example. So now we have a times 2 in the front. All right, and so if you remember from before, again, I would pause and think about it, but once you have your answer, the answer is this makes it stretch, all right? And it always stretches in the vertical sense. But I think to help us understand this a little bit more, I made a table here. This is the original function, just the absolute value of x. And so if we have 2 times absolute value of x, all that happens is these numbers after you do the absolute value like we did before, you just take them times 2. Okay, so it's just going to literally double, if Master Hospital can double correctly here, it's just going to double all of these output values. All right, and so conceptually all that happens is it just goes up twice as fast as it did before. Right, so when we're at, I'm going to take 0, 0, that point's the same. And then let's do 1 and 2. So 1, 2 is right here. And then 2, 4. I'm not going to plot all of these, but there's 2, 4. Okay, and then 3, 6. And we'll see that it's actually this number for an absolute value one turns out to sort of be the slope. All right, so what do we have in this case is actually the same V, but it got stretched vertically. And what that really means for absolute value graph is that it has that slope. So it has a 2 slope. Technically, the one side is a -2 slope, but it's 2 on this side, -2 on that side. So it just goes up faster than it did before. Okay, so I'm not going to do another example of this, but the idea is, this is the slope. So for this particular example, our slope would be 1/2. We would have our V, and then our slope would just be a 1/2 slope, so up 1 over 2 on both directions like that. Okay, so with absolute value, that's a little different than before. It's at that number's the slope. All right, so let's see if we can throw a bunch of this stuff together. All right, let's try let's see, I'm going to find one here. Let's try this. All right, so again, I put on here, like, if you're not sure, you can always graph on a calculator if you're really not sure what's going on here, but you can also do it first and then check on your calculator. In a lot of ways, this is pretty fast once you get used to it. Pause the video and then give it a shot. All right, so here's all what happened. This went up 3. This is opposite of what we think. So instead of left 1, that's right 1. And this is now like the slope, all right? And it's technically it's going to be a compress because it's between 0 and 1. But I'm just going to draw right 1 up 3. That's our new center point that we're going to start from. And then I'm just going to have a 1/4 slope. So I'm going to go up 1 and over 4. All right, and then do the same thing this way. Technically, it's a -4 slope on that side, but you know, once you get to one side, you can just do kind of reflect it across, and boom, you're done. All right, let's see what else we got here. Oh yeah, so this would be a good one because this now has a negative here, which we haven't done one like this yet. All right, so again, give it a shot. If you can get this, you definitely are okay on this lesson. All right, here we go with your answer. Again, hopefully you already have this done and you're just checking with me. This makes us go up 4. This makes us go, let's see, I think right, so it's actually going to be left 1. And then a couple things. So this is the hardest part here. It's kind of like 2 parts. So the 2 part is going to make us sort of stretch, right? So we'd have a 2 slope, but we're also going to be flipped upside down because of the negative part. So that's going to be reflect over the x-axis, right? Because the negative's on the outside. So instead of like a 2 slope going up, it's a v going down. All right, so let's plot this to be as clear as we can. So I go left 1 up 4. There's our center. And again, instead of going our slope of 2, so instead of our v going upward, it's going to go downwards with a slope of 2. All right, so I'm just going to draw some points here. And this has got a slope of 2 to 1. Right, so it's a pretty steep v. Just instead of going up, it's going down. Okay, and that's because of the -2 instead of the +2. So this one looks like this. All right, if you got this and feel comfortable, I would recommend not watching the rest of this, right? So I'm just going to show you our goal was to graph, right, absolute value functions, right, knowing what their parent looks like and then transforming it using the calculator to check. So if you're good, here is the homework, and you can just start rocking it. If you are unsure, you can write down this homework, but then I'll do a couple more examples here if you need them. All right, so these are the extra examples if you weren't sure. Here's one more example, and I think the hardest part is this negative. Okay, so when you see a negative, a multiplying with a negative, it's going to reflect, right? But the tricky part is like, is it the x-axis or the y-axis? Okay, so I'm going to start with the easy part actually. This +3 makes us, because it's on the inside there, that's going to make us go left 3. Okay, and then this negative, because it's on the inside, if it was on the outside, if it was out front here, that would reflect over the x-axis, but because it's on the inside, that's going to reflect over the y-axis. Okay, so this is probably a good example to watch here. I'm going to go left 3, 1, 2, 3. So that's where my v normally would be. Right, I can start to just kind of draw it in here. It's got a regular 1 slope, right? But because of this negative, it's going to flip it. So I'm going to do another color here, and I'm going to flip it over. So here's my y-axis, and this point goes here, and then goes the same amount on the other side. So it got reflected right there. So now my v is over here. The starting point got reflected across the y-axis, and then I'm going to draw my regular v from there. All right, so just going to draw my 1 slope v, because the basic slope is 1, right? So my final answer is that black graph that you see there. All right, hope that helps. Good luck with the assignment.